There is one button combination that resets your Subaru's computer instantly. Not a dealer visit, not a scan tool, not a $150 diagnostic fee just to clear a code and reset a system that would have fixed itself with the right procedure. One button. Available on every Subaru built in the last 15 years, accessible from the driver's seat in under 2 minutes, and capable of resolving a list of problems that most owners assume require professional intervention. Check engine light that came back on after the problem was fixed, transmission that's shifting oddly after a battery replacement, fuel economy that dropped for no obvious reason, idle that's rough and inconsistent since the last service, EyeSight that keeps giving false warnings, climate control stuck in a mode it won't exit. All of these and more can be resolved with a proper computer reset procedure that most Subaru owners have never been shown. Here's why this matters financially. Dealers charge $100 to $200 just to connect a scan tool and clear codes. They charge another $100 to $150 to perform reset procedures that, in many cases, you can accomplish yourself in your driveway with no tools and no equipment. I've watched owners pay $300 for a service visit that consisted of a technician performing a 3-minute reset procedure and handing the car back. The exact same procedure I'm about to show you for free. But here's what makes this video different from every other how to reset your Subaru ECU video you've seen. I'm not just giving you one reset method. I'm giving you the complete reset hierarchy, the right reset for the right problem, in the right order, so you're not wasting time with a basic procedure on a problem that requires a deeper reset. Because not all resets are equal. A soft reset fixes different problems than a hard reset. A module-specific reset fixes things a full ECU reset won't touch. Knowing which to use and when is the difference between a 2-minute fix and an hour of frustration wondering why your reset didn't work. Today, I'm walking you through the complete Subaru computer reset system. Every level, every application, every problem it fixes and doesn't fix. Let's get into it. Why Subaru computers need resetting. Before the procedures, understand why this happens so you know when a reset is the right solution versus when it isn't. Adaptive learning gone wrong. Your Subaru's ECU constantly learns and adapts. It learns your driving patterns and adjusts shift points. It learns fuel trim corrections to compensate for sensor drift. It learns idle characteristics based on accumulated throttle body deposits and intake system condition. This adaptive learning is designed to improve drivability over time, but it can also learn incorrect values that degrade performance. After a repair that changes how the engine breathes, a new air filter, throttle body cleaning, intake work, the ECU's learned fuel trims may be based on the old dirty condition. The car runs correctly, but the ECU is applying corrections that are no longer appropriate. After a CVT fluid change, the transmission's learned shift adaptation may be calibrated around old degraded fluid characteristics. The new fluid behaves differently, and the transmission hunts for shift points that no longer apply. A reset clears these learned values and forces the ECU to relearn from a clean baseline, which matches the vehicle's current actual condition, rather than its remembered historical condition. Corrupted memory states, sudden power loss, dead battery, blown fuse, jumpstart event can interrupt a write operation in the ECU memory, leaving corrupted data in a control module. This corrupted data can cause any number of symptoms. Check engine lights for systems that are functioning correctly, modules that won't communicate properly, systems stuck in fault, states they can't exit normally. A proper reset clears corrupted memory and allows modules to reinitialize from a known good starting point. Sensor recalibration needs. After certain physical repairs or replacements, sensors and actuators need to relearn their calibration. Steering angle sensors after wheel alignment, throttle position after throttle body cleaning, transmission after fluid service. These recalibrations happen automatically during the reset-relearn cycle. Level 1. The soft reset, the one button. Here it is, the one-button reset that most Subaru owners need most of the time. This is the correct first step for almost every Subaru computer complaint, and it resolves the majority of adaptive learning problems without affecting long-term module memory or requiring any reconnection procedures. The procedure: turn the ignition to the on position. Do not start the engine. Every warning light on the dash illuminates. This is normal. Wait 30 seconds with the ignition on and the engine off. Turn the ignition off. Wait 10 full seconds. Turn the ignition back to on. Again, do not start the engine. Wait another 30 seconds. Turn ignition off. Wait 10 seconds. Now start the engine normally. What this does: this double cycle procedure forces every control module on the network to complete a full self-diagnostic cycle twice in sequence. Modules that were stuck in fault states get the opportunity to retest the conditions that caused the fault. If the underlying problem no longer exists, the fault clears. It also prompts the ECU's short-term adaptive memory to reset while preserving the long-term learned values that represent genuine calibration data. What it fixes: check engine lights that returned after a repair was completed, intermittent warning lights with no consistent cause, climate control systems stuck in incorrect modes, EyeSight warning lights after windshield cleaning or camera adjustment, rough idle after a brief period of abnormal operation, transmission shift hesitation after a short-term disturbance. What it doesn't fix: active faults with an underlying physical problem that still exists, long-term adaptive learning that needs to be cleared completely, module calibrations that require position relearning. Level 2. The throttle body reset. The throttle body reset is one of the most practically valuable Subaru-specific resets and one of the least known. Every time you clean your throttle body, replace your air filter, or do any work that changes airflow through the intake, the ECU's throttle position and idle air calibration needs to be reset. Without this reset, the ECU continues using its old throttle body calibration, often causing rough idle, hunting idle, or higher than normal idle RPM after intake service. The procedure: ensure the engine is at full operating temperature. Do not attempt this on a cold engine. Turn the ignition off. Wait 10 seconds. Turn the ignition to the on position. Do not start the engine. Wait 3 seconds. Slowly press the accelerator pedal fully to the floor over approximately 5 seconds. Not quickly, slowly. Hold it fully depressed for 5 seconds. Slowly release the accelerator over approximately 5 seconds. Not quickly, slowly. Wait 10 seconds with the pedal fully released. Start the engine and allow it to idle without touching the accelerator for 2 full minutes. During those 2 minutes, the throttle body actuator runs through its full range of motion, and the ECU relearns the closed and open positions from the new baseline. After the 2-minute idle, the idle quality should smooth out noticeably. If it doesn't on the first attempt, repeat the procedure once more. What this fixes: rough or hunting idle after throttle body cleaning, high idle, 1,200 to 1,500 revolutions per minute that won't settle after air intake work, hesitation on initial acceleration from a stop, idle that varies with climate control and electrical load in an uncontrolled way. Before we continue, reset procedures like these are most effective when they're part of a complete maintenance approach rather than reactive fixes for problems that have already developed. I've documented the complete proactive system in the 500,000 mile car maintenance blueprint, link in the description. Level 3. The CVT relearn procedure. The CVT transmission has its own adaptive control module that learns shift patterns, belt pressure, and ratio selection based on the driver's habits and the transmission fluid's friction characteristics. After a CVT fluid change, the transmission's learned adaptations are calibrated to the old fluid. New fluid behaves differently. Without a transmission relearn, the CVT can hunt between ratios, shudder during acceleration, or apply incorrect belt clamping pressure. The procedure: After CVT fluid service, begin with the Level 1 soft reset above. With the engine fully warmed up, find a safe road with no traffic. From a complete stop, accelerate gently to 30 miles per hour using light throttle. No more than 25% throttle application. Come to a complete stop. Repeat this sequence 5 times. Now, accelerate gently to 50 miles per hour using moderate throttle, approximately 40 to 50% throttle. Come to a complete stop. Repeat this sequence 3 times. Finally, accelerate to 60 miles per hour using approximately 70% throttle. Come to a complete stop. Repeat once. This graduated relearn sequence forces the CVT controller to sample its new operating environment at progressively higher load levels, building a new adaptive map from scratch that matches the fresh fluid's actual friction characteristics. What this fixes: CVT shuddering after fluid service, hesitation or hunting immediately following fluid change, incorrect shift feel compared to pre-service behavior. Allow 200 to 500 additional miles of normal driving for the adaptation to fully complete after this initial relearn sequence. Level 4. The hard reset, battery disconnect. When the Level 1 soft reset doesn't resolve the issue, the next step is a full hard reset via battery disconnection. This is more comprehensive than the soft reset because it completely clears all short-term and long-term adaptive memory, forcing every module to rebuild its learned values from absolute zero. The procedure: turn the ignition completely off. Remove the key or ensure push-button start is fully off. Open the hood. Disconnect the battery negative terminal using a 10mm wrench. With the terminal disconnected, press and hold the brake pedal for 10 full seconds. This drains capacitor charge from the electrical system and accelerates the memory clearing process. Wait 15 full minutes. This is non-negotiable. Capacitors in modern Subaru control modules maintain enough charge to preserve memory for 10 to 12 minutes after battery disconnection. Only after 15 minutes is memory definitively cleared. Reconnect the battery negative terminal. Tighten firmly. Turn the ignition to the on position. Do not start the engine. Wait 60 seconds for all modules to initialize and complete their startup self-diagnostics. Turn the ignition off. Wait 30 seconds. Start the engine. Allow it to idle for 5 full minutes without driving. This gives the ECU time to begin its idle relearn before it encounters driving loads. During the first 50 to 100 miles after a hard reset, drive gently and vary your speed. This gives the ECU the range of operating conditions it needs to rebuild accurate adaptive maps quickly. What a hard reset fixes: everything the soft reset fixes, plus persistent problems the soft reset couldn't resolve. Fuel trims that are stuck at incorrect values causing rich or lean running. Transmission adaptive values built on incorrect historical data. Persistent module communication errors. Post-battery replacement drivability issues. What to expect after a hard reset? The engine may idle slightly rough for the first 10 to 20 minutes of driving. This is normal. The ECU is relearning idle from scratch. Fuel economy may be slightly worse for the first 200 to 300 miles. Again normal. Fuel trims are rebuilding. The transmission may shift differently for the first 100 to 200 miles as adaptation rebuilds. All of these normalize as the ECU accumulates operating data and rebuilds its adaptive maps. Level 5. The steering angle sensor reset. This specific reset is required after any wheel alignment, any steering component replacement, or any time the vehicle pulls to one side, or the stability control system activates incorrectly. The steering angle sensor tells the EyeSight system and the vehicle dynamics control system where straight ahead is. If this calibration is off, stability control interventions happen at incorrect times and EyeSight lane departure warnings trigger on straight roads. The procedure: find a flat, straight, empty parking lot or road. Drive in a perfectly straight line at exactly 20 miles per hour for a minimum of 30 seconds. Come to a stop. Turn the steering wheel to full left lock. Hold for 3 seconds. Return to center. Turn the steering wheel to full right lock. Hold for 3 seconds. Return to center. Drive in a straight line again at 20 miles per hour for 30 seconds. The steering angle sensor recalibrates automatically during the sequence, recording the true straight-ahead position and the full lock positions as its new reference points. On 2015 and newer Subarus with EyeSight, the system may require a 5 to 10 minute drive at highway speeds after this procedure, before fully confirming the new calibration. What this fixes: stability control activating on straight roads, EyeSight lane departure warning triggering incorrectly, pulling sensation that appears after alignment work, pre-collision warning system reacting to non-existent hazards. Level 6. The full module reset via fuse pull. For situations where specific modules are stuck in fault, states that even the battery disconnect reset couldn't clear. Targeted fuse pulls reset individual modules without affecting the rest of the vehicle's learned data. The procedure: with the ignition off, locate the interior fuse panel, driver's side, behind a cover near the left knee area. Using your owner's manual fuse diagram, identify the fuse for the specific module you need to reset. Common targets: HVAC fuse resets climate control module. EyeSight fuse resets the EyeSight camera module specifically. Audio/Starlink fuse resets infotainment system. Meter fuse resets instrument cluster. Pull the identified fuse and leave it out for 5 full minutes. Reinsert the fuse. Turn the ignition on and wait 60 seconds before starting to allow the reset module to complete its initialization sequence. This targeted approach resets only the problematic module while leaving all other modules' learned data intact, which is advantageous when you know exactly which system is causing problems. The complete reset decision tree. Use this sequence to choose the right reset for your specific problem. Warning light appeared recently. No apparent underlying problem. Start with Level 1 soft reset. Idle quality issues after service or cleaning. Go directly to Level 2 throttle body reset. CVT behavior changed after fluid service. Use Level 3 CVT relearn. Multiple systems misbehaving or soft reset didn't work. Go to Level 4 hard reset. Stability controller EyeSight issues after alignment or steering work. Use Level 5 steering angle sensor reset. One specific system stuck in fault state after all other resets. Use Level 6 targeted fuse pull. Underlying physical problem confirmed. No reset will fix this. Repair the problem first, then use the appropriate reset to clear the resulting codes and recalibrate. What no reset can fix? Be clear about the limitations. Computer resets resolve software states, calibration errors, and adaptive learning problems. They cannot repair physical failures. If a sensor has failed, resetting the ECU clears the code temporarily, but it returns when the ECU tests the sensor again, which is usually within the first drive cycle after the reset. If a mechanical component has failed, no software reset addresses that failure. The sign that a reset isn't the solution, the fault code or symptom, returns within 1 to 3 drive cycles after the reset. This consistent return pattern indicates an underlying physical problem that needs repair. The bottom line: the complete Subaru computer reset hierarchy. Level 1 soft reset. Double ignition cycle with 30-second holds. Fixes most adaptive learning and stuck fault states without clearing long-term memory. Level 2 throttle body reset. Slow pedal depression and release sequence after intake service. Fixes idle quality problems after cleaning or airflow changes. Level 3 CVT relearn. Graduated acceleration sequence after fluid service. Fixes shift behavior and shuddering after transmission maintenance. Level 4 hard reset. 15-minute battery disconnect with brake pedal drain. Fixes everything the soft reset addresses, plus persistent issues requiring complete memory clearing. Level 5 steering angle sensor reset. Straight line driving plus full lock sequence. Fixes stability control and EyeSight calibration after steering or alignment work. Level 6 targeted fuse pull. Module-specific power interruption. Fixes individual stuck modules while preserving other systems' learned data. Use the right level for the right problem. Start at the lowest level that addresses your specific symptom. Work up the hierarchy if the lower level doesn't resolve it. The vast majority of Subaru computer problems that owners pay $100 to $300 to have reset at a dealership are resolvable with these procedures in your own driveway. And if you want the complete guide to maintaining every system your Subaru's computer monitors and controls, check out the 500,000-mile car maintenance blueprint in the description. If you found this video helpful, be sure to watch this next video as we're sharing insider tips to help you cut repair costs and keep your car running like new.